Hello friends, in the previous video, we have seen the problem on stresses in beams, type 2. In this video, we are taking type 3rd, beam subjected to both hogging and sagging bending moment. See this problem. The cross section of beam as shown in figure. This is the cross section, given cross section. You can see the rectangular cross section, hollow rectangular cross section. The dimensions are given. This dimension is 50, this one is 75, this is a 25. Then here you can see 25, 50 and 25. Determine the maximum tensile and compressive stresses when the beam is subjected to uniformly distributed load of 2 kN per meter and length of span is 3 meter. For first condition is given, that is cantilever. Another condition is simply supported. The beam resists bending moment about neutral horizontal axis. You can see the beam is subjected to uniformly distributed load, that is 2 kN per meter, means W is given, that is 2 kN per meter, and the length is given, that is 3 meter. Remaining dimensions are here. See, first step, to find out position of neutral axis, means we have to find out the Y bar in this diagram. So Y bar is equal to A1 Y1 minus A2 Y2 upon A1 minus A2. See, because this is the hollow rectangular portion, larger rectangle minus smaller. So A1 Y1 minus A2 Y2 upon summation of all the area, that is A1 minus A2. So according to this, for the first rectangle, you can see the area, that is 15,000, because it's 100 into depth 150. So 15,000 into the total height is 150. So Y1 is 75 minus area 2, that is 75 into 50, that is 3,750 into Y2, that is 50 plus 75 divided by 2, that is 87.5. Here we have A1 minus A2, you will get Y bar, that is 70.83 mm. See, means here you will get the Y bar from base. The distance of neutral axis is Y bar, that is 70.83. After getting the Y bar, you can calculate IXX. To calculate IXX, here you can take IXX1 minus IXX2. We know that how to calculate IXX1 by using parallel axis theorem. Here the parallel axis theorem is IG1 plus A1 H1 square minus IG2 A2 H2 square. According to our regular process, we have the dimension of rectangle, we have base, we have depth, we have area 1, then difference between Y bar and Y for rectangle first and rectangle second. According to, you can calculate the moment of inertia. I is equal to 25.59 into 10 raised to 6. Then you can see the case 1. Once you will get the value of Y bar, then this one is a Y bar, that is 70.83. The neutral axis is passing through here. So 70.83, total distance is 150. So accordingly, you have to consider for cantilever, bottom portion, or you can see the lower portion below the neutral axis, that is Y bar is equal to YC, that is 70.83, and YT is equal to, means upper portion, that is 150 minus 70.83, that is 79.17 Newton per mm square. Here we know the formula for bending moment of cantilever, that is W L square by 2 from chart. If you don't have chart, then you can calculate bending moment for cantilever by using our regular process. Answer is 9 kilonewton into meter. Now we know the flexural formula, or you can say the bending formula. F by Y is equal to M by I. Here we have the value of FC. We have the value of FC and YC. See, we have to calculate value of FC. We have the value of YC, M and I. So stress in compression, that is FC, is equal to, sometimes instead of F they are using sigma, so it will be sigma C, or you can say FC is equal to M by I into Y by YC. So we have the value of YC. Here you will get compressive stress, that is 24.91 Newton per mm square. Formula is same. Instead of compressive stress, there will be a tension, that is FT. FT is equal to M by I into YT. So here YT is 79.17. We have the value of M, we have the value of I. You will get FT 27.84 Newton mm square. This is the case 1. In this, we have the value of YC and YT. Lower value is a compressive value, upper value is a tensile value. But in the case of simply supported beam, Y bar is equal to YT and YC is equal to 150 minus YT. Means upper portion is a compressive and lower portion of the neutral axis is tensile. That is simply supported beam. Already I explained during the theory part. So M is equal to W L square by 8 for simply supported beam from the chart. If you don't have chart, you can calculate maximum bending moment for simply supported beam. Here we have the values. So M is equal to 2.25 kilonewton into meter. After getting the value of M, I and YC, you can calculate compressive stress. Similarly, you can calculate a tensile stress also. So here we have the value of compressive stress, that is 6.96 Newton per mm square. FT is equal to 6.23 Newton per mm square. Here you can see the stress distribution diagram, bending stress distribution diagram. This is the given cross section of the beam. For a cantilever, you have to draw a baseline. This dotted line indicates the neutral axis where the bending stress is equal to 0. See, for a cantilever, you can see this is FT, that is 27.94, and FC, here you can see 24.91. Below the layer, that is compressive stress, and above, that is tensile. But in the case of simply supported beam, again this one is a vertical line. This portion is shows the value tensile stress, and this one is compressive stress. The next video we will see another type. Thank you very much.